Hello everyone, good morning. So today we are going to start with chapter number 4 of class 8 Cbse, right? So we are going to start with chapter number 4 of Cbse science, that is electricity, right? So we are going to start with electricity. Now in this chapter we are going to learn about the two effects of electricity, that is magnetic and heating effect, right? Now if we talk about the electricity, what exactly is electricity? So electricity is basically the flow of charges. When the charge flow from one place to another place, it creates electric current, right? What it creates electric current, and the energy that arises due to which, right, the energy that arises due to the flow of these charges, it called as electricity, right? Now it is called as electricity. So in this chapter we are going to learn about the two effects. First we are going to talk about the magnetic effect. Second we are going to talk about the heating effect. So let us start with it. Now the next thing is the mystery of hookless screen. Now just see this screen. Now the screen is able to pick up so many irons material, right? It is able to pick up so much iron material and it is able to drop it somewhere else. How this magic is happening? This magic is happening only because of the magnetic effect of electric current. Yes, it is happening because of magnetic effect of electric current. Now how can an electric circuit behave exactly like a magnet? So the question is, electric circuit is behaving like a magnet, how it can happen? So let us understand it. Now if we talk about the magnet, right, just a second, let me change the color. Yes, now if we talk about the electric circuit, basically, so electric circuit is nothing but the path for current, right? Basically the electric current. So it is the path for the electric current to flow, and we have learned in the previous classes there are two types of electric circuits, right? First is open circuit, another one is closed circuit, right? So whenever the circuit is closed, right, whenever the circuit is closed, then only the current can flow in through the circuit, right? Let's just say that this is circuit, this is, I have made a bulb and then I connected it with a battery, right? I made it directly. Now when we connect it with a battery, right, so this battery, as soon as the current will flow through this circuit, so the path here, you can see this path, right? The path which you are able to see over here, this path which you are able to see over here, this is the path for the electric current to move, right? So the path for the electric current to move is called as the electric circuit, and we have two kinds of circuit, right? Now who found that this is going to create the magnetism? How this circuit can create the magnetism? Let us understand it. So here is Sir Hans Christian Ørsted. Now Hans Christian Ørsted was a professor and he mistakenly discovered this effect. He was taking lecture in his class, right, and he was taking lecture on something else, and then he kept the compass near this setup which you are able to see over here. So when he kept his compass near this setup, he saw deflection in this compass needle. This compass needle started to deflect. Now how it happened? That is what lead us to the discovery of magnetic effect, right? So if you want to take the notes, take down the notes. Sir Hans Christian Ørsted, he was a Danish scientist. In 1820 he accidentally discovered the magnetic effect of electricity. How he did it? He was taking some lecture. So what he did is he kept a circuit, he closed the circuit and just placed the compass. So if we also take a circuit, right, and place the compass near it, and then whenever we connect the switch to on, right, so here we can see that the current flowing through the conductor will create a magnetic effect around it, right? So this conductor, this wire is creating a magnetic effect around it, and due to this the compass needle over here starts to show the deflection. The deflection is here because of the magnetic effect, right? So whenever a current carrying wire, let's say I have a current carrying wire, so when the current flow through this wire, right, when the current flow through this wire is going to create a magnetic effect around it, right? This wire is going to create a magnetic field around it, and that is what called as the magnetic effect of electric current. So in the simple way you can understand it like that: whenever the current will flow through the conductor, it will produce a magnetic field around it, right? And that is what called as the magnetic effect. You can check this effect with the help of compass. You can place a compass over there below the wire, and then you can see the deflection, right? Now let us move ahead and let us make a magnet for ourselves. How we can make a magnet for ourselves? So we can make a magnet for ourselves just by doing these things. Just a second, let me change the color of the pen. Yes, so here we have to take a copper wire, right? We have to take a copper wire, and then we have to wound the wire around the iron nail. In the first picture you are able to see over here, we need to wound the copper wire around an iron nail, and then we have to make the loop such that they are tight enough, right? It should be tight enough, and then we have to connect the two free ends to the battery. One will be connected over here, another will be connected over here. So we have to connect it, and as we connect it, then after some time you will see that the iron pin, the paper clips will start to get attracted to it, right? So these are the steps to make the electromagnet. Now if you will keep on connecting it for a long period of time, the battery will get heated up, right? The battery will get heated up. So be safe while doing this. Now, have you noticed what are the three things that we have used over here? Yes, the three things that we have used over here is nothing but first is wire, right? What are we making with wire? We are making loops with wire, right? So here this one is a loop, so we are making loop with wire. Second, we have used the iron nail, right, because we wound the wire on it. Third that we are using over here is battery, right? So do remember these three things, because these three things are going to help us. Now let us see that how can we increase or decrease the magnetism in our temporary magnet, because the magnet that we have built over here, this one is not going to pick up the iron trash from the scrapyard that we have seen in the first slide, right? So that means I need a powerful magnet, right? And that powerful magnet can be generated or not. Let us see. So if we talk about the electromagnet, in the electromagnet we can change its strength. Yes, for the electromagnet we can change the strength of electromagnet. How it can be done? It can be done by the three things that we have used to make the electromagnet, right? But before that, let us talk about electromagnet. What exactly the electromagnet is? Electromagnet is basically a current carrying coil, right? This is a coil of wire over here, so it is a current carrying coil that behave as a magnet, right? It is a coil, right? It is a coil of copper wire which is going to act as a magnet. But when it is going to act as a magnet? When current flow through it, right? So a current carrying coil that act as a magnet is called electromagnet, or a coil of a wire which produces magnetism as a result of electric current is called as electromagnet, right? Now we can amplify the strength, as I told you, we can amplify the strength. How can we amplify the strength? We have to see the three things. What those three things are? The first is turns, right? More the number of turns, more will be the magnetism. Why? Because if we talk about the one single turn, right, as the current is flowing in it, this one single turn is going to produce its own magnetism, right? So one single turn is going to produce its own magnetism, and we have number of turns over here, and as we have number of turns, each one is going to add up. Therefore, more the number of turns, more will be the strength of the electromagnet. Second is current. Now we are using battery, right? So if we increase the number of battery, what will happen? If we increase the number of battery, then what is going to happen? The amount of current will be more, because the electrons in the conductor will get more power to run, right? So as they will be getting more power to run, they will be running too quickly, and we have high amount of current. So as we increase the current, the intensity or the strength of the electromagnet also increases. The third factor that we are going to talk about is here the core. Now here you can see that we have put the iron nail. What if instead of iron nail I'll put a paper inside it? Yes. Is it going to work? Yes. Now suppose I have taken a straw, and on this straw I want the copper wire over here, and then I connected this copper wire to the battery, right? Then as I'll be connecting it to the battery, is it going to generate the magnetism? Yes, it is going to generate the magnetism. It is going to generate magnetism, but the strength of the magnetism will be weak. Why it will be weak? Because the magnetism which is going to be generated over here is only because of the current which is flowing in this direction. As the current is flowing in this direction, now the domains of the wire, right, herein in the wire there is certain region in which the electrons are there, and each of the electron is moving here and there, right? So we need something to align these electrons, right? And the iron nail over here act as that agent. When we put the iron nail and wrap the copper wire around it, so because of the current which is flowing in the one particular direction, the domains of the iron nail also get aligned in this direction, right? And as the domain of iron nail also aligned in one particular direction, the magnetism, the strength of the magnetism increases. So if you put any of the magnetic material over here, the strength of the magnetic electromagnet will increase. And if you do not put anything, if you just simply keep the wire, then also the electromagnet work. And if you put something else, non-magnetic thing, then also the it will work, but the strength will be very less. So here we discussed about the three things on which the strength of electromagnet depends. First is the iron core. If the iron core is there, then the strength will be high. Then second, we discussed about the number of turns. So if we increase the number of turns, then it is going to increase. Third is the intensity of the current. If the intensity of the current increases, then the power of the electromagnet will increase, otherwise it will decrease. Now one more thing, just as the bar magnet, you all have seen a bar magnet, right? It is north and south over here, so it has two poles. In the same way, our electromagnet is also going to have, say, two poles. It can be north and south, and we can change the pole of the electromagnet with the help of battery. How? For example, I want this pole over here to be south and this pole over here to be north. So what I'll be doing, I'll reverse the connection with the battery. On reversing the connection of the battery, right, on reversing the connection of the battery, I can alter the poles of the electromagnet. For example, I'll show over here. This is my iron nail, right, and I connected it like this, right? And suppose that this is north pole and this is south pole, right? Now here I have connected the positive this side. Let's say this is A and this is B. Now when I'll change the battery over here, let's say I have made the, just a second, I'll connect into it only. Let's say I have here, I have changed the connection now, and here I have made this connection now I have connected with the negative, and this I have connected with the positive. So this side now will be no longer north, it will become south, and this will become north. So just you will you turn the battery, then the poles of the electromagnet is also going to be changed. Now applications, where can we use this electromagnet, right? We have prepared the electromagnet, but where are we going to use it? So we are going to use it in scrapyard, because it has the ability to turn on and off. For example, if you want to pick up a car, right, and then you need to drop it also, right? Otherwise what is the need of it, right? So it has the function of on and off, therefore we can use it as per our requirement. For example, here you can see we have picked up the trash over here, and as we have picked up the trash, now I need to drop it somewhere else also, and as I'm going to drop it somewhere else also, so I need something which can turn the magnetism off, otherwise I won't be able to put it off somewhere, right? So for that, what I'll be doing is I'll be turning off the the magnetism, and as soon as the current will stop, the magnetism will be lost and everything will be dropped, right? Now other than that, we used in the school bells, right? When the current will pass through it, then magnetism will be created, and as a result this hammer is going to hit the gong over here, and as the hammer is going to hit the gong, the circuit will become incomplete, and then again the hammer will come back, and the same cycle will repeat it. In the electric motors we use it, and in the loudspeaker to amplify the sound we use it. Now let us move forward to the heating effect, but before going to the heating effect, let us quickly revise what we have learned. We learned about the magnetic effect of electric current. So in the case of magnetic effect of electric current, right, a wire is there, and a wire is there, and when the current will flow through this wire, it will generate a magnetic field around it, right? And that was given by Hans Christian Ørsted. Second, we learned about the electromagnet, right? Electromagnet is a tool which generate the magnetism with the help of electricity. So here magnetism will be created as a result of current, electric current, and based on that we have made a device, that is electromagnet, and power of electromagnet can be turned on and off. The uses are school bell, electric motor, electric cranes, and then loudspeaker. Other than that, we can use it at many places, right? And the strength of this electromagnet depends on the three things. First is core, second is current, and third is the number of loops. Now let us move forward to the heating effect. Now the second effect over here is, have you seen that when the bulb keeps on glowing for few hours, it will become hot? The bulb starts to get hot. Why? Because of this second effect, which is called as the heating effect of electric current. Now in the heating effect of electric current, why the device get heated up? The device get heated up as a result of resistance, as a result of electric resistance, right? Now let us understand what exactly the heating effect is. For example, I connected the wire with a battery and I'll turn on the switch. Now as the switch is turned on, the current will flow through this, and after some time some of the electric energy will get converted into heat energy. What is happening over here? The electric energy is getting converted into heat energy, and as the electric energy is getting converted into heat energy, I will start to feel the hotness over here, and that is what called as the heating effect of electric current. Now let us understand why it happens. So it happens because of the resistance, right? Now you can understand the resistance in class 8 as the electrical friction. Now what is going to happen is, we know that each and every conductor is made up of certain atoms. Let's say these green ones are the atoms over here, right? And as these atoms are here, and when I connect it with the battery, so the conductor will get the energy, and the electrons which are there associated with these atoms, right, which we call as the free electron. These electron will get the energy and they will start to run, and as they will start to run, the atom left over here will be called as the ion. Okay, now when the electron will run over here, in the same way there are many ions present over here, and then these electrons are going to collide with the ion, and when the collision will happen, right, when the collision will happen, what is going to happen? Electric energy is going to convert, electricity is going to convert into heat energy, right, and as a result we are able to feel the hotness in the conductor, and the phenomena of collision of electron with the ions is called as the resistance, right. Now let us understand it again. So here I have this conductor. Okay, now in this conductor the electrons are flowing over here, electrons are flowing. Now as the electrons are flowing, there are certain ions also, right, so the electron is going to collide with these ions, and when the electron is colliding with the ion, the speed of the electron decreases, they are not able to flow with that much energy, right. So the electric current over here decreases, right, electric current decreases, right. So this opposition which the electron is facing, right, यहाँ पर जो electron को opposition मिल रहा है, right, by these ions, that is called as the resistance, the opposition or the hurdle in the path of the electric current, right. Now when the resistance is when the opposition is felt by the electrons, this energy is getting converted into heat, therefore we are able to feel this heating effect, right. So more will be the resistance, more will be the heat, and less will be the current in the conductor, right. Now let us move forward. Now our magic star of the day is nichrome. Why nichrome? Because nichrome is having high resistance, and we already learned that high resistance will be equals to high heat. So if we want to produce heat somewhere, we need the higher resistance, and therefore we make an alloy which is called as nichrome, in which nickel and chromium is used, right. And when we mix the nickel and chromium and make a alloy, it has higher resistance, right, and as it is having higher resistance, we use it on all the heating devices. And the coil of the nichrome which is used over here, you can see the red colored coil, the red color coil you are able to see over here, and here this red color coil is known as the element. This coil over here is called as the element, heating element basically. This is called as the heating element. So heating element is nothing but the coil of wire which is used for heating, right. Now where we can find the application, we find its application in electric room, electric heaters, stoves, kettles, hair dryers, irons. These are the places where we use it. Other than that, we use it in the furnace to melt up the metal, right. To melt metal, we use this effect in the furnace to run the furnaces. Now the next and the main topic over here is voltaic cell. Now the cells which we are using right now, how they were made, what has given the inspiration for the preparation of this type of cell? That is nothing but the voltaic cell. Now a cell is a device which generates the voltage, right, it gives us the voltage. Cell is a device which produces the electric energy as a result of the chemical energy. Now how it happens is, we in the voltaic cell there are two things, right. So two things, first thing over here is electrolyte, and second thing over here is electrode. These are the two main things that you need to remember. Now if we talk about the electrolyte, electrolyte is any chemical which conducts the electricity. Chemical which conduct the electricity is called as the electrolyte. A chemical which conducts the electricity is called as the electrolyte, and here we take the electrolyte as the weak acid. It can be a weak acid or it can be a salt solution, right? So it can be a weak acid or it can be a salt solution. Then electrodes are nothing but the metal plates which are used, or metal rods which are used for the conduction of the electricity over here, right? So here we have used two different material. We have used zinc electrode and we have used copper electrode, and electrolyte over here we have taken as the dilute H2SO4. We have taken dilute H2SO4, that is sulfuric acid. Now what will happen is, when I have taken a beaker, I put the sulfuric acid into it, and then I dropped these two electrodes, and as soon as I drop these two electrodes, we know that zinc is more reactive, right? So as zinc being more reactive will start to react with the sulfuric acid. So here the zinc over here will start to react with the sulfuric acid and it will convert into zinc ion. So from here the zinc will be released into this solution as a Zn2 plus, and 2 electrons will leave over here, right? So here we have 2 electrons. Now this process will keep on continuing, and here we have negative charges. So this buildup of negative charges make the zinc as anode, the negative electrode. This buildup of electrons only make it up as the anode, that is the negative, right? Negative electrode, anode. Now after that, what is going to happen over here is, these electron will feel repulsion after some time. As they will get accumulated over here, they will feel repulsion, and as a result of repulsion they will start to move, and as they will start to move, they will be received over here by this copper, right? And as it will be received over here by the copper, the current will start to flow in the opposite direction of the electrons. Now what will happen to the electron over here? So this sulfuric acid is going to dissociate into hydrogen plus and SO4 2 minus, right? So here the sulfate ion is going to mix with the zinc and we are left with hydrogen. So hydrogen ion will get accumulated over here, and as it get accumulated over here, therefore this terminal will get the positive charge, and therefore it is called as the positive electrode, that is cathode, right? So the electrons which are coming over here are received by this hydrogen over here, and then it will get converted into or liberated in the form of hydrogen gas. It will be released over here as a hydrogen gas. Forgot this reaction over here. It is going to released in the form of hydrogen gas, and therefore from here we have the movement of H, and SO4 is going to get involved with zinc, and as a result of this, what is going to happen? A complete circuit is here, and therefore if we connect any of the bulb over here, it will start to glow. The bulb will start to glow, right? So that is how the voltaic cell works. Now it will keep on working, but one time will come that this electrode will vanish, right? The zinc will be vanished, that is it getting dissolved in the solution. And the nature of this solution, now earlier it was sulfuric acid, then it will become ZnSO4, it will become zinc sulfate, and as it will become zinc sulfate, it is not able to conduct the ions and the electrons will not flow, so the working of the voltaic cell will be finished, and then it will be called as the dead cell, right? It is not able to generate further energy, right? So this is all about the voltaic cell. Now let us move forward and discuss the primary and secondary cell. Basically the primary cells, these are the cells which are non-rechargeable. We cannot recharge these cells, and the secondary cells are the ones which can be rechargeable. They are use and throw cells. In this we have chemicals which are present over here, right? And the reaction in these cells is irreversible. You cannot reverse the chemical reaction over here. The AA size battery of Eveready and then Duracell, Panasonic, these are there, which are generally these primary cells only. We use it in wall clocks and TV remotes and many other things. Generally we use it in our daily life. Now if we talk about this secondary cell. In the secondary cell, the chemical reaction can be reversed by passing current. You all have seen mobile phones and laptops. When the battery is less, then what is going to happen? We put it into the socket, we charge it, and then again a battery is 100%, right? So here when we pass the electric current, the chemical reaction can be reversed, and as the chemical reaction can be reversed, we can charge it. Therefore they are called as secondary cells or rechargeable batteries. Now let us discuss about them. Now here we have dry cell. Now how the dry cell is made up of? Again, the two things which we have discussed are there. First is electrode is also there, and second is electrolyte. Both the things are there, electrode and electrolyte. Now if we talk about the electrode, here we have electrode in the form of carbon rod. Now the carbon is a bad conductor, it is not going to conduct the electricity. So here we have taken graphite, which is a form of carbon. So we take a graphite rod over here, you can see it over here in the center, right? And the another electrode will be zinc. Another electrode will be zinc casing. You can see over here the outer cover, that is zinc casing. So again the carbon act as a positive, and the zinc, this outer casing of zinc, it act as a negative electrode, right? And then inside it we have a paste of electrolyte. Now here the electrolyte is in the form of moist paste, right? It is not exactly dry, but it is in the moist form, just like the toothpaste. So it is in the form of moist, which doesn't leak, so therefore it is portable. You can take it from one place to another place, right? And therefore as it is dry in comparison to the voltaic cell, therefore the name dry cell is here. Okay, now here when you connect it to the circuit, what is going to happen? The chemical reaction in between these electrolytes is going to happen, and as a result electrons are produced, which electron travel through these carbon rod and the zinc container and flow through the circuit, right? And that is how the electric energy is going to convert, chemical energy is going to convert into the electric energy. Now the next is our lemon battery. Now if we talk about the lemon battery, so here what is going to be the electrolyte? The electrolyte is basically the juice which is present in the lemon. This juice is acting as an electrolyte, and then we have two electrodes over here, right? And as soon as you connect the two electrodes and number of lemons, you are going to connect it with the LED. The LED is going to glow. So that is how the lemon battery is. Now if we talk about our secondary or rechargeable batteries, if you talk about the rechargeable batteries, so we have lithium ion batteries. Now lithium ion batteries are rechargeable or secondary cells which are used nowadays in a high amount, right? As they are more eco-friendly in nature. Now if we talk about the lithium ion batteries or secondary cell, the chemical reaction can be reversed, right? The chemical reaction can be reversed. How the chemical reaction can be reversed? It can be reversed by giving electricity. As you will supply the electricity, the chemical reaction is going to change and the original material will be there. For example, you have taken an electrolyte, let's say you have taken a certain electrolyte, it get used up, and then now the phone's battery is, let's say, 10%, and now you want to use it. So what you will be doing at this step, you will be charging it, right? So this phase is called as charging. When you are supplying the electric energy to the cell, it is called as charging. Now that will take up that electric energy and convert this electrolyte into original form, whatsoever the original form of the electrolyte is. And then after the original form, let's say your battery become now 100%, and again you are using it. So the time then you are using it is called as the discharging phase. It is called as the discharging phase when you are using. Let's say you are using your laptop right now. So when you are using, when the battery is degrading, it is going down, that phase is called as discharging phase, and when you put it into the socket for charging up your laptop, that phase is called as charging. So at the time of charging, the chemical which got mixed up will again start to get separate, and after certain time it will brought back to its original form. Therefore we call the batteries, the chemical by the electricity, the chemical reaction can be reversed. Right now, nowadays the batteries are made up of lithium ion, and the electrolyte is also the mixture or salt of lithium, because it is more lightweight and it can supply massive amount of energy, and it is more eco-friendly. Now, how can we dispose the battery? We cannot dispose the battery anywhere, right? Because it contains the toxic chemicals and metals which, when leak into the soil and water, it will be harmful. Therefore we need to dispose it safely. What we can do is, we can just take up the battery, identify the type of battery, right? Identify the type of battery, and after identifying the type of battery, you can tape its corners or the terminals, tape the terminals, and then bag it safely, right? Separately you can bag it, and as you can bag it separately, when you are going to put it into the garbage bin, there is a black color box for e-waste. You can put it there, so that whatsoever material or metal which is recoverable, we can recover that metal, right? We can recover that metal, and when the metal will be recovered, we can use it again. Rest will be again recycled, right? That is how we have to discard our batteries. Now let us move forward, and here let us check our knowledge. So an electric current flow through a nichrome wire for a short time. The wire become warm. A magnetic compass placed below the wire get deflected. Choose the correct option. Now both will be the correct answer, because when you connect the nichrome wire to the battery, this resistance is high, and because of the high resistance it will become warm, and as the current is also flowing, so it will show the magnetic effect also. So both are correct. Now voltaic cell is a chemical reaction cell, and electric iron is heating effect. Now if we talk about the secondary cell, that is lithium cell, right, which we have talked about, lithium ion batteries. So these batteries are not for lifetime, right? They are not for lifetime. They have certain specific charging cycle, after which they have specific charging cycle, and after that cycle they will get dead, right? So they are not like this ki once you have purchased it and then it is going to act forever. No, they have a certain charging cycle, and after some time it is not going to be recharged. You all have seen that when you use the mobile for 2 to 3 years, let's say, so after certain period of time, the battery of the mobile, the efficiency of the battery is not up to the mark. So because you pass the electricity, some of the chemicals are not going back to its original state, because of which the efficiency of the battery decreases. Now here you have 4 identical coils made of iron, copper, aluminium and nichrome. Which one will get the hottest when connected to the same battery? So nichrome, as we have learnt, its resistance is too high. Now next, you reverse the battery terminals of an electromagnet. What happens to the compass needle placed nearby? So the compass over here will start to deflect in the opposite direction. Next, look closely at the circuit setup. What will be the compass show in each scenario? As it is connected over here, so the compass will show the deflection over here, and as here we have open circuit, so no deflection will be there. Now this is the mind map. You can see over here we learned about the electric current, 2 of its effect, magnetic effect. We can make the electromagnet. The factor that affect electromagnet is number of turns, and the current, and the iron nail over here. Its uses, it is used in cranes, in bells, and then the next we learn about the heating effect. Now heat effect arises due to the resistance when the electron faces the opposition because of the ions. Then because of this, the electric energy get converts into heat energy. The element is the coil of wire which we use in our heating devices. Basically we use the nichrome wire because it has high resistance. The uses are in the in the iron we use it, in the heaters, in the toasters. Then we learn how we make the electricity from chemicals. So we do it with the help of cells. Then we learned about the initial cell, which is voltaic cell, the first cell. Then we have series of cells. We learned about the dry cell, in which the chemical or the electrolyte is in the form of moist paste. Then we learn about the secondary cells, which can be recharged and reused again, in which we use lithium ions. Then the safe disposal of battery is necessary, because otherwise the chemical will leak into the environment and it will be very harmful, right? So this is all for today. Bye bye everyone, we will meet in the next class. Till then, stay connected.